Hello friends, today we are discussing the topic I2C communications in the subject microprocessor. Okay, so this is the subject microprocessor in which we will discuss about the topic I2C, which is the communication protocol, some part of the parallel line. We will discuss here the what is the pros and cons of the parallel lines, which this is from the series of the lectures, the SPI, serial parallel inputs lines. Pros: the fast and easy. What are the advantage and disadvantage? We can say it. Okay, now it is a fast and easy. So SPI, it is a serial parallel communication, which is a fast and easy. First, for a point to point communication, that means whenever we connect serial lines or any devices, the communication will be taken as fast, but it is an for point to point communications. Easily allow streaming constant data flow, as it is a point to point communication. So a streaming or a data flow from one point to the another time point is done easily. No addressing, simple to implement. So no addressing is needed, as it is for point to point communication. Serial parallel line is for point to point communication. No addressing is needed. It is simple for implementation. Everyone supports it. That everyone supports it means every devices which we see in our surrounding. That is in case of the, suppose the monitor connected to the CPU. This is also a serial line connections. A bit by bit is sent, whereas the printer connected to the CPU or the processor. So this is also a serial port communication. So everyone supports it. That means whenever a device which is connected for point to point communication, there a serial communication lines are used where the a bit by bit transmission is done. So what is the disadvantages? What is the pros? We will discuss here now. What is the cons? Now we'll see what are the cons of this serial parallel communication. Serial communication makes multiple slaves very complicated. So in which we can't able to connect a multiple slaves, because multiple slave connection and master slave configuration, it makes it a very complicated. No acknowledgement ability means, as we are unable to connect a master and slave, even we connect it, it becomes a very complicated. And a master slave configuration through the serial port communication is very complicated. As it is complicated, also there is a disadvantage that no acknowledgement liability ability is there. Means once data is transmitted, there is no possibility of sending any acknowledgement. We know in the today's day of the internet world, acknowledgement is much more important. Whenever any data is transmitted or any information is transmitted, we a sender, a receiver, machine gets an acknowledgement. That means if acknowledgement is there, sender machine comes to know, or sender node comes to know that a data is transmitted successfully, received successfully. So it can, a sender machine or a sender node can able now to transmit get data at a same rate. But if there is no acknowledgement, how a sender come to know that a data is received at the another rate successfully? So this is one of the disadvantage of here. No inherent arbitration. So here arbitration is no flow control. Flow control again is there. Okay, if we are sending a streamlined data of the 2 GB data is sending from one node to the another node. This 2 GB data is divided into the small chunks known as packets. These packets may be received one by one at the another end. Acknowledgement may be generated in case of that acknowledged service cases. Okay, and if a flow control is measured, means a sender and a receiver can able to access, able to handle that many of the packets, and that is the flow control. Okay, Here the flow control is not available in case of the serial communications. Now we'll see the I2C buses in our subjects. That is a communication with the accelerometer. This is a communication with the read from the accelerometer, pros and cons. The communication with the accelerometer I2C. The pros are the simple wire connections. Two wire bus can connect multiple peripherals with the MCU, master slave configuration, or a MCU, multiple connecting units. Two wire buses. Only the two wire bus is there. It can evade. It is a what are the advantage of the I square bus? It is a simple wire connections, not in complicated wire connections. So two wire buses that can connect a multiple peripherals with the MCU. A disadvantage complexity is significantly higher as we just uses the two wires for connecting the multiple peripherals, so the complexity becomes so much higher. How to operate the camera? So MCU I square said I square register one register to the spring. So how a camera is operated by using this much, okay, by MCU is there in which the I square C buses are connected through the register 1, register 2 and the spring. So it will operate the camera in this way. I square 2. It has a two lines, serial data lines and serial clock lines. Serial SDA, that is the serial data lines, SCL, that is the serial clock lines. Only two wires of the connecting multiple devices. These two wire goes through the from the microcontroller that connects to the number of devices. I square peripheral devices 1, peripheral devices 2, peripheral devices 3. There are only two lines, SDA, serial data lines and a serial clock lines. What is the need of the data lines? Data line, through the data line data is transmitted. It is the use of the clock line. A clock line is synchronized. Once the clock line is synchronized, a data which is transmitted from source to the destination is received within that time limits, okay. So it can, a synchronization is done here, that's why the clock line is there. Only two wires for the connecting multiple devices are there. Each I square C device is recognized by the unique addresses. So each device having its unique addresses, each device can be either transmitter or a receiver. Each device can operate as a transmitter or a receiver, or it can send a data or it can receive a data. So both can be possible by the device which is connected in a I square buses. I square devices can be master or the slave for the data transfer. It can be possible a master slave configuration here in a as square devices. The master, usually a microcontroller, initiates a data transfer on the bus, generate the clock signals to permit the transfer and terminate the transfer. So what is the master? Master is generally a microcontroller which is connected in that system, acts as a master. The master initiates the data transfer on the buses. This master, if has a certain data which initiates the data transfer on the bus, generates a clock signals to permit the transfer. Here also the master generates the clock signal to permit the transfer. So these clock signals plays an important role in every communication parts and terminates the transfer. At the same time, at the end of the communication, the master sends the termination of the transfer. That means a three-way handshaking is here. It initiates the data transfer, it generates the clock signal, and it terminates the transfer of the data. Slave, any device is addressed by the master at that time. What is the slave? Slave means any device connected in that network or in that line which may access a master at any time, or any device addressed by the master, or that means a master who communicate with the another device. In that case, the another device becomes a slave, okay. So this is a I2C detail. The bit transfer on the I2C bus. The normal data transfer, the data line only exchanges the data state when a clock is low. A SDA, when a clock is high, it will transfer the data when it is a data line stable data valid is there. And in the normal data transfer, data lines only changes the state when a clock is low. When a clock is low, at that time the data lines changes state. When the clock is high, it doesn't changes the state. That means a continuously change of the data is allowed. If clock is low, at that time the change of the data is allowed. Data line is stable for a data value. Means whenever the clock is steady or a clock is high, at that time a data line is stable. And but when a clock is low, at that time a data transfer is not done or a change of the data is allowed. Start and a stop condition. The transition of a data line while the clock line is high is defined as either a start or the stop conditions. A transition means change in a data line. Okay, a change in the data line while the clock line is high is defined as a start or a stop line condition. Even if the clock line is high, okay, and there is a change in a data line is there, that means it is a start and or a stop condition may be there. So both the start and stop conditions are generated by the bus master. The start condition or the stop condition which may be generated by the master itself by looking up the clock signals. The bus is considered busy after the start condition until a stop conditions occurs. The bus is considered busy after a start conditions until a stop conditions occur. I square C addressing. I square C addressing. Each node has a unique bit addresses. In I square C addressing, each node has a unique 7-bit addresses. A peripherals often have fixed and a programmable address portions. A peripheral often have a fixed and a programmable address portion. Addresses starting with the 00 or a 111 have a special function. 00 is a general call address. 0001 is a null address. 11x address extension. 11 is the address extension. Next bytes are the actual addresses. Address starting with the 00 or a 111 having a special function. 00 is a general call address. 001 is a null address. 111xx address extension 1 and a 118 time the 1, that is an address extension. Next byte are the actual addresses. I square C connection system. How the systems are connected in a I square C communication system or a line. The SDA or a SCL, microcontrollers, LCD drivers, gate arrays, ADC, analog to digital converters, static RAM or a EEPROM. These are the number of devices connected to these two lines. Okay, so one of the at the same time a number of devices can connect it to this two lines bus system, and a serial communication or a multi-device communication, that is a master slave configuration is done here, but a complexity is increases as a number of devices is increases because it consists of only the two lines for the communication. That means at a time some restriction is there. Okay, some of that devices can't able to communicate, and as it has no acknowledgement policy. Okay, so these are all how the I square to C connections systems are there. Master slave relationship, how to the master slave relationship between the I square C. Who is a master? Who becomes a master? Master transmits and a master receiver. A master The device who is a master, which may be generally the microcontrollers or a microprocessor or a processors, which can able to transmit or which can able to receive the devices or a data. Suppose the microcontroller wants to send the information to microcontroller B, or a microprocessor A wants to transfer information to the microcontroller B. A master addresses the B slave. At that time, suppose here a microcontroller A and a B are communicating. So how the master slave relationship is there? So one device become a master, the device who is sending the information become a master, a device who is receiving a information becomes a slave. This is an master slave configuration in which a device transmitter sends a data to B device and terminates the transfer informations. Okay, uh, this is an vice versa. So if a B wants to communicate with the A, at that case the B becomes a master and A becomes a slave. B transmits a data and A receives the data, and at the end the termination of the link or the terminates the transfer. If the microcontroller wants to receive the information from the microcontroller B, if a microcontroller wants to receive the information from the microcontroller B, a master addresses the microcontroller B. A master addresses the microcontroller B. A master receives the data from B. A terminates the data. A master addresses the microcontroller B. A master receives the data from the B. A terminates the transfer. In both the cases, the master generates the timing and A terminates the transfer. In both the cases, master generate the timing, that is the clock signal generation is done by the master node, and terminate the transfer. It also sends a termination signal as a trans communication is ended. The master sends a termination signal, so both the devices terminates the communication, and it will allow another devices for communication with that master. Exercise how the fast can I square C run? How the I square C can run in a fast? How fast can it run as shown in the figure? The graph changing the timing as a percentage of the supply voltage changes as the it can fast. Assumption zeros are driven and ones are pulled up. Some working figures are there. Exercise bits read vs useful data, right? An I2C transaction involves the following bits: S A6 to A0, read write A D7 to D0, and F. Which of these actually carries the useful data are? So if a bus runs at a 400 kilohertz, what is the clock period? What is the data? What is the bus efficiency? Thank you friends for watching the video.